with option choices. You'll have A, B, C, D, E, as well as an option called still solving. So still solving tells me that you are actively engaged in the session. So when enough people mark still solving, I know, okay, these many people are engaged. So I have 11, just 17 people till now who say they're ready for the question. We have 83 participants at the moment in the session. Show more participation. Show me that you're ready for this. At any time, I will tell you answers when I have responses from at least 70 to 80% of the actively engaged people. And I'm judging the actively engaged from still solving. So make sure you mark still solving every time before we have a new question. All right, we have 40 some more people. Let's interact a little more here. Let me know we're all ready to go into the first question. All right, here is question number 1 called question 8 because this is what is going to come in the end. Good luck, everyone. Last 15 seconds before I end the poll. Please make sure you mark your answers. All right, so here I end the poll. Now let me broadcast the results so you can see how you people have voted as a group. So as you see, we had 25% votes for A, 54% for C. Well, I'm not going to discuss the answer to this right now, but see how the majority has gone with option C. Remember this, I will bring this back later on, but for now the majority thought that you need both of these statements to answer this question. Now I'll clear this poll and reopen this for the next one. Please mark still solving, and then I'll show you the next question. All right then. Here's your next question. Question number 9. Good luck, everyone. Last 10 seconds before I end the poll. Make sure you put in your answers before then. And we're done. I will end the poll and show the results to you. So look how this has been really divided. We had 13% with A, 6% with B, C, D, and E are almost constant, 23%, 24%, 21%. Just remember this later on. I'm sure you can't remember the numbers, but when I bring this back up, you will see why this is so important. Now, this I will clear the results, and again, you know the drill. You will again click on still solving, and that'll tell me you're ready for the next one. Challenge question number 3, question number 10. Come on, we have 31 votes right now. We have 87 participants. I'll show you the question once we reach 60. Right. Here you go. Question number 10, everyone. Good luck. Is there some confusion? I'm opening the short answer pod. Please tell me if you guys are seeing this question number 10 for the first time, or you have already solved this. Please continue. Thank you. Last 15 seconds and I'll end the poll after that. Please make sure you put in your answers. And we're done. Here I end the poll. And let's see the results. Okay, so all of you, here are the results for your reference. We can see that the majority this time went with option D, but we had 13, 10, 14, 9%, fairly an equal spread in the other four options as well. Later when we come to this, of course, you know the drill, we will talk about this. Now, these are the three that we're all aiming for. I'm opening the short answer pod. Please tell me what you think about these three questions. How did you feel while doing them? All right, you can all see each other's responses here. Confusing, challenging, super tough. Somebody said they were fun. Wow. So somebody said we need some revision. All right, so you can see how the majority here, most of you, in fact, almost all of you said that these were tough. So when I asked the same question towards the end, and if I get the answers to the same question as, oh, we could do them easily, that will measure success for all of us together in this group. So now you know what you're going for. You know this is what you will get ready for. The next thing up, as you know by the progression of the session, is the warm-up section. Warm-up section, as I said, will just include basic questions on divisibility and remainders, and this will tell you where you currently stand, whether you're using the correct formulas or not. Solutions will be there, but these are so basic that we would not go into excruciating detail about them. We would not need all that detail. So here I am going to show you question number 1. We have a new poll for this one. I'll bring that up, but the drill is still the same. You know it's still solving, and I know you're ready. And here the poll is open. Full energy, people. I really like how quickly you guys this time marked still solving. Here is your first warm-up question. Good luck. Last 5 seconds before I end the poll. Please mark your answers. Let's get everybody's responses here. And here we end the poll. All right, now this time we are going to discuss the solutions simultaneously. So let me first broadcast the results. You see how you people have voted. We had 19% of you who said it's option A, that Z may be divisible by 3. 66%, which is a huge majority, went with option B, that Z definitely is divisible by 3. We had just 1% of you saying it's not divisible. So the majority is correct. Congratulations. It indeed is B. How? Now let's discuss that. So what do we have? We have that Z is a 3-digit number, right? Just give me 1 second before I activate my pen here. All right. Okay, so Z is a 3-digit number whose digits are consecutive numbers in increasing order. Now, consecutive is what? When you have numbers coming one after the other. So 1, 2, 3, 6, 7, 8, all of those are consecutive numbers, and we had to accordingly select the correct statement. Now, please tell me in the short answer pod, what was your method of doing this? What was the one thing you used in solving this question? Okay, so I see x, x plus 1, x plus 2. You are telling me how you represented the consecutive numbers here. But what was the idea? What was the concept that we've used here? What did you do with that x, x plus 1, and x plus 2? What is the underlying concept? Consecutive numbers was just the definition. The concept here. Average of 3 numbers. Yes, sum of digits. Why are we doing the sum of digits? What is that method all about? Why are we doing that? Well, we had a lot of answers who said the one thing that I know about divisibility and remainders, they are the divisibility rules. Well, here is the first divisibility rule for you. It's the divisibility rule of the number 3. So what we know is that a number is divisible by 3. The divisibility rule is that the sum of its digits should be divisible by 3. And that is why when you assumed the digits to be x, x plus 1, and x plus 2, you added all 3 of them, and the sum that you got was 3x plus 3, which always is divisible by 3 because you can express it as 3 times x plus 1. Now, if the sum of the digits is divisible by 3, then z is always divisible by 3, right? So please tell me if everybody now is super comfortable with this. Just tell me in the short answer pod only. If all those people who got this wrong are now absolutely clear why the answer is B. Okay, great, great. We're all comfortable with this now. With this, we are ready for the next warm-up question, question number 2. Remember your takeaway from every warm-up question. Your takeaway from here was the divisibility rule of 3. Please mark still solving so I know you're ready for the next one. Great, great. That's quick participation. Here is question number 2, everyone. Good luck. Okay, I'm ending the poll in another 3 seconds. 3, 2, 1, and we're done. Okay, let me broadcast the results quickly. So what do we have here? So you see how 54% of you went with option A, 7% with B, and 33% with C. Wow. So it was B clearly lost here, but we had a huge percentage that went for option C. Now, the difference here is that option A says it may be divisible by 4, while option C says it is just not divisible by 4. Let's see. Nobody thought it's always divisible, so we're good there. Well, the correct answer for this one is option A. So, yes, the majority is correct, but it's very important we understand this one properly because 33% is not a small number. Let's discuss this one. Well, Z is a 4-digit number whose digits are consecutive numbers. So it's again consecutive, the same thing that you had for the previous question. This time though, the divisibility rule is of 4. So I'm reopening the short answer pod. Please tell me what the divisibility rule of 4 is. Two digits. Yes, last two digits should be divisible by 4. A lot of you say that. So you know how this works. You know how the last two digits are what determine divisibility by the number 4. So good. That is really the core concept that you have here. So if people did not get this right, then probably they did not consider every case that there is to this one. Let me show you what I mean. Well, divisibility rule, as you guys just said, the last two digits should be divisible by 4. But remember one thing, last two digits, yes, they are going to be consecutive because all 4 of the digits are consecutive. But what all can they be? Well, if the first two digits are 1 and 2, then the last two can be 3, 4, 4, 5, 5, 6, 6, 7, and so on. So there are possibilities in which your Z is odd. An example here is 2, 3, 4, 5. Tell me one thing, if it's odd, are we not already very, very sure that it is not divisible by 4 in that case? At least for the case when it is odd. Yes, we are absolutely sure if z is odd that there is just no question about it being divisible by 4. So everybody here, probably this was one of the examples why you thought, oh, it's not always divisible by 4. But the people who marked C, they might have considered this. So this is not where we faltered. Look at the other situation now. When Z could be even. Well, even, look at this one example. 3, 4, 5, 6. What are the last two digits? It's 56. 56 is divisible by 4. 56 is divisible by 4 and therefore 3, 4, 5, 6 as a whole is divisible by 4. That is what the divisibility rule says. That means Z could be divisible by 4. It may be divisible by 4. So all those people who said it's not divisible, they missed this one case that the last two digits actually can be divisible by 4. Maybe they just could not, okay, you feel silly. You just didn't think enough. So this is how you just have to think about everything. You have to think of all the cases that there are to any problem. It's a common mistake that people make. You know, they think about 10, 15, almost everything, but there's this one thing they just don't think about, and the exam traps you right there. So it's all of these things you have to be careful about. It's a simple question, but see how 33%, 34% went wrong with this. So everybody now is absolutely comfortable about this one. Please tell me how you feel about this now so that I understand that you're all ready for the next one. Okay, great. Please mark still solving to tell me you're ready for warm-up question number 3. Okay, very nice participation. 40 people marked within seconds. All right, 50. Great. I will now show you question number 3, everyone. Good luck. Okay, we have votes from everybody. Here are the results. You see how the majority is just great this time. 95% of you went with option C, and that is correct. So very, very few mistakes for this one. That tells me we don't really need to go into that much detail this time. That tells me you know the divisibility rule of 10. So let me just bring in the solution and let's talk about it. Divisibility rule of 8 is when the last 3 digits should be divisible by 8. Now here 897 is what we have. 897 is not divisible by 8. We really need to find the one number closest to 897. The rest of it you can just repeat. All of these digits you can keep as it is. It's only the last 3 that you need to work with. Now the closest, how do we find it? Well, 897, if you divide that by 8, your remainder is 1, which means 897 has one extra from a multiple of 8. That is what is remaining. Remainder is the extra stuff, right? Which means 896 is perfectly divisible by 8. And so the closest number would be when you just replace the last 3 by 896, which is exactly what you have here in option C. Tell me in the short answer pod if you did it this way, and if not, how did you do it? So all of you are doing it with the correct approach. I'm very, very happy to see that. It's the perfect approach you're all applying. Now, again, I will clear this and you will have to, again, you know the drill, mark still solving. So I know you're ready for question number 4. Okay, 23 votes. We have 100 people. Come on, let's have at least 80 of you actively engaged in this. You can see the numbers growing there. I've broadcasted all of this. 54, 55. Come on. Okay, all right. So for all of you who are ready, here is question number 4. Good luck. Last 10 seconds before I end the poll. Please mark your answers. Let's end this. Okay. I will broadcast the results for all of you. You see how the majority went with option D. The majority is not as huge this time as the last one, but 70% is again great, which is correct. Of course, D is the correct answer. Let's discuss this and then I'll ask you if your approach matched mine. Well, what do we have here? We have that a number n leaves a remainder of 3 when it is divided by 204. What is the remainder when n is divided by 4? So we don't really have this number n. All we know is something about this number n. Now what happens if I divide it by 204? Then my remainder is 3. So without even having this dividend, the number n, we want to get the final remainder. Well, here is the core concept. A lot of you said in the beginning you know about this equation. Dividend is equal to divisor times quotient plus remainder. So in my case, the information that I already have is this. What is the dividend here? Well, the dividend is n, the remainder is 3, and the divisor is 204. So I use all of that here to write this equation. Well, I don't know the quotient, so I'm just calling it Q for now. So this is what I'm given in the question. Is everybody absolutely clear about what is given till now and how we've represented that using our equation? Wonderful. Now let's see what you want. What do we want in the question? Well, we want what happens if it's divided by 4. Well, that does not mean you apply the equation any differently. It's still the same thing. You still have to do the same thing, which means this time your dividend is still n, your divisor is 4, the quotient is p, which you don't know, and r is the remainder. It's this remainder, it's this r that we need to find out. Now there's one key information here, the remainder can never be more than the divisor. Well, why would you stop dividing if you still have a greater divisor? Think about it, you're dividing by 4 and the remainder is 5. Well, you will continue. It'll be 4 ones are 4 and then the final remainder will be 1. So you never stop unless your remainder is smaller than the divisor. Now, this is where I want to reach. This is my goal. But I have to get here from what I have. This is what I have. So from having 204Q, somehow I want to change that into 4 times something. Well, this is really simple. 204 is actually 4 times 51, which means 204Q is the same as 4 times 51Q. Now this 51Q thing here becomes your P, and therefore if P is 51Q, you can rewrite 204Q as what? 4 times 51Q, which is 4P actually. So it's N equal to 4P plus 3, and therefore the remainder is 3. Why do I not need any more processing? Well, this is the one condition I wanted to take care of, that my R should be less than 4, and it really is less than 4. Are we all very clear about this now? Is this how we solved it? And if not, tell me how you solved it. All right, so I see some responses saying they're still confused. Don't worry, this is the first time we're doing it. The confusion is natural. We will get rid of this in further questions. Many people said they plugged in 207, so they plugged in one number. Well, for this one, it is correct. It's okay to plug in. But when the level of your questions increases, your plugging in method is not going to work. And that is why when we began the session, I talked about this unified approach that is going to work forever. It's that approach we're working towards, and that is this concept of dividend, divisor, quotient, remainder, this relationship. You will see how, if you practice this enough, if you apply this on every question, this will become second nature to you much faster than plugging in. So for now, I'm assuming everybody is comfortable at least with this solution. Tell me if all of you at least understood what we did here, even if your approach was different. We have a lot of Y's here, so everybody is comfortable with this, and it is very important because this is what the whole session stands on. It's super important. Question number 5 now, when you see, I forgot to ask you to do still solving, but it's okay. This is the next one you're doing. Try to apply what you learned in question number 4 on this one. Good luck. Ending the poll in another 5 seconds. Make sure your answers are in. Okay, I'm ending the poll here. Yes, I can see the answer choice is visible. I don't know how that was missed, but let's see if everybody got it correct for the correct reasons. Just getting the correct answer is not the point here. You all have to be sure of why something is the answer and something else is not. So now that you see the results, you see 60% of you marked A, and that is absolutely correct. So the majority is correct this time. But we have a huge majority for option D. 20% of you, 7% say B also. So the ones who marked D, you just missed that one key piece I talked about, that the remainder can never be more than the divisor. Well, the divisor is 5 here. You're dividing by 5. How can your remainder be more than 5? How can it be 6? Do you now realize what I'm talking about? And the people who got this correct, tell me what was the one difference between question 4 and question 5. Perfect. It was just this fact that the first time the remainder you got was greater than the divisor. So we needed one extra layer of processing there from where we had started. Here is your solution. We are again using the same equation. Well, what do we have here given? When n is divided by 205, the remainder is 6. So this is how we express that using the remainder equation. And this is where we want to get. What happens if you divide it by 5? This is the R that you want. Now again, see how I've written the constraint here that R has to be less than 5. So when you first express it and you get R equal to 6, you had to go on further with it and break it down one more time. So apply the same equation, the divisibility remainder equation, one more time with the same divisor, 5. So 6 itself can be written as 5 times 1 plus 1. So the final remainder is this little one here. Are we all absolutely clear about this one now? Please tell me the ones, the 18% plus the 7%, the 25% who got this wrong. Are we all comfortable? Crystal clear about this. So again, anybody, any confusion, remember remainder has to be less than the divisor. If it's not less than the divisor, you apply the same divisibility remainder equation one more time, and then you will have your final remainder. Now with this, we are done with the warm-up section. The overall feedback here for you is you have to have 200% clarity in concepts. If there's any lack here, any little miss that you have at this stage, it is going to compound in the tougher questions. There you will not even know what to do, how to start. So you have to be very clear with everything here. So if you scored less than 100% in these questions, that means you got even one question wrong. Make sure you revise the relevant concepts from our course. You have this available in your free trial. GMAT questions require a much advanced level of this. So this much at least has to be perfect, has to be perfectly clear. So tell me in the short answer pod, how are we all feeling after this warm-up section? Sounds wonderful, great, good, all warmed up, great. So we're all feeling a bit more confident. Well, wonderful. If this confidence keeps increasing till the end, you will see a new you. Ready for the tough question? Wow, that makes me sound wonderful, makes me feel wonderful. Now, after this, before I go on to, the progression of the session, those problem-solving questions, here's a little something I want to talk about. It's a study plan. It's a student-wise, a tailor-made study plan that you can get for yourself instead of, following the general. Sometimes you get confused. Oh, I'm studying, but I still don't know why. I can't figure this out. So you need help from an expert. You can schedule an appointment with one of our GMAT strategy experts who will help you do this properly, Atreya will share a link. When you click on the link, step 1 for you will be to choose the tile which matches your problem area. So you see how this place somebody has highlighted timing issue. So there was this one person who, suppose you're somebody who's struggling only with the time, then this is what you select. Somebody else might feel, oh, I got my verbal score is stuck. Then you will select this tile. So you select the relevant tile. Once you do that, your next step will be to click here to seek help. Help me reach my target score. So this is what you want us to help you with. When you click with this, you will get this option. You will have a lot of time slots available here. Select what is convenient to you, just how it's highlighted in the picture. Once you do that, there will be this questionnaire where you will fill some basic details about you. You know, just so that we don't talk about everything on the call and we have an idea about you, your aspirations beforehand, it will help us prepare better and help you better in the call. I hope everybody is clear about how this is going to work. Make sure you get this, and this is this strategy, this correct helping hand right in the beginning will take you to your goal very soon. Everybody clear with what has to be done, right? Everybody clear? Please tell me in the short answer pod. All right. With this then, we are ready to go back into our session. What do we have here? We have GMAT style questions, 600 level on problem solving this time. So problem solving questions, these are, of course, you know there are two types of questions. There is data sufficiency and there is problem solving. So we are going to have problem solving questions, and since these are proper GMAT style questions, you are now going to have 5 answer choices, A through E. Again, all you have to do is mark E to tell me you're ready for this. I'm sorry, I meant you have to mark still solving if you're ready for this. I said E. E is one of the answer choices. Still solving means you're ready for this. And we are all ready for question number 1 in this. Good luck, everyone. Another 15 seconds before I end the poll. All right, so let's end the poll and broadcast the results. So you see how 57% of you, the majority, went with option C, which is correct. So congratulations, everyone. But this is almost half of us. The other half was not very sure. Now, you might already have seen here that this is a question where if you actually solved it, it will take a lot of time. Tell me in the short answer pod if your approach was that. Did you solve for m first, 30 multiplied by 8.2, and then divided it by 15? Or was your approach any different? Okay, most of us said yes, you solved this. Some of us tried to use the approach. Wonderful. I'll show you how the approach will make this super simple and you will not have to solve for the value, not do any such multiplication. Think about the numbers getting harder or larger numbers. That would take you a lot more time. See how we should do this. Well, here is the solution. First step, you know, again, that is the equation we will rely on. Dividend is equal to divisor times this and that, where remainder is less than 15. How do I already know that? Because my final divisor is 15 and I know the remainder is always less than the divisor. Now, when that is done, what my goal is to express this number m as 15p plus r. So again, using this equation here, and it's this r that I want to find out. I want to find out the remainder. But what I have is this thing here. So first of all, I know I want m equal to something. So I will first find out m from this. It will become 30 times 8.2, but this is still not the form I want. I want 15p. I want 15 times something. How do I get 15 from this, and what do I do about this decimal? It's 8.2. Well, step 1 is to break this like this. It's 30 times 8 plus 30 times 0.2. So what happens as a result is this second bit, 30 times 0.2, that just becomes 6. But then again, we still don't have the 15 that we were looking for. Well, now it's easy. 30 can be written as 15 times 2, right? And what will happen as a result is this 2 will partner with the 8 that you already had. It'll become 16, and that becomes your P really. It had to be 15 times something plus R. So when you compare it, the R that you have is 6, and all it was supposed to be was it had to be less than 15, and 6 is already less than 15. So our answer is option 6. Option C, which is 6. Tell me if you're crystal clear about this now. And also tell me how this compares with your method of actually solving the value. What do you think is the difference between the two? Do you see how this helps? Absolutely, it's faster, it's very neat, it's scalable. Thank you, I am the best. That's so sweet, you made my day. Okay, lightning fast, 30 seconds saved, wonderful, versatile. So all of you can see how this is super helpful. And now promise me this is what you are going to try for every question that comes ahead. Now that you've seen the magic that this has, let's see this in action for the next one. I'll clear the poll here, tell me still solving, and I will show you the next one. Okay, just 7 people. Okay, 15. Come on, let's show more participation here. Okay, here is question number 2. Good luck, everyone. Last 10 seconds before I end the poll. Please make sure you have your answers in. All right, so here we're done. Let's broadcast the results. So you see the majority, 79%, okay, a greater majority this time, went with option C, which is correct. I hope all of you did use the correct approach this time. And tell me in the short answer pod if you did and how you feel you've already changed, evolved from question 1 to 2. Okay, great, we used that. Good. Wonderful. Let's discuss the solution together. And so anybody who was confused will now feel more comfortable. So again, the goal starts first. You want the remainder when m is divided by 30. So this is what you want it to be, 30p plus r. And this r is what you want. It just has to be less than 30. That's all. That's all the goal is. Then you go back to what is given to you. M by 15 is 8.2, but I want m equal to something. That means I take 15 to the other side. Yet again, you split it, the decimal part, the 0.2 goes away to the other side, and you have 15 times 8 on one side. Well, what I want is 30p, and again, you know how you get 30? It just has to come from this 8. You have to give 15 an extra 2, and when you do that, you'll only be left with a 4 from the 8, and 15 times 0.2 is 3. It just perfectly fits into the equation we wanted to bring this into, and when you compare, R is 3. I hope everybody is crystal clear about this one. The next one will require slightly more processing, so you have to be very, very comfortable with this one. Tell me you are ready for the next one by marking still solving. The poll is now open. All right, here is question number 3, everyone. Good luck. Last 10 seconds before I end the poll. Please put in your answers. All right, so here we end the poll. And here are the results. 68%, again the majority this time, went with option E, which is the correct answer. So the majority is always right on all of these. That's great. But we see the next biggest share went to option B, which is 3. So from 18 to 3. Tell me one thing, for all of those people who marked 3 in the short answer pod, did you divide 18 by 15 again? Because you thought it was greater than 15? Tell me in the short answer pod if that is what you did. Right. Okay, so people who got 3, there is something else that's going on. All right, I will ask you that after I explain this one to you. Let me explain this solution first of all. So what is going on again? We have m, a positive integer. We again have something given here. We want the remainder when m is divided by 30. You again know the goal. The final equation, the stage where you want to take this is this. M is equal to 30p plus r, and this r just has to be less than 30. That's all the goal that there is. Now from m over 15 equal to 9.2, you get this one. M equal to 15 times 9.2. This time again, first step is still the same. You split it. The decimal part goes away. This is 15 times 0.2. This is where you get the 3. Maybe this is the 3 you straight away marked and did not take care that you wanted it to be 30p. Not just 15p. I'm reopening the poll. Tell me if this is where you got the 3 from. So this is where it happened. Great. I'm glad we at least found where the problem arose from. But I hope you now see the problem with this is it's 15 times 9. It has to be 30 times p. And if you just thought it's 15 times 2 times 4.5, then you're wrong. Why? Because in that case, 4.5 will become your p, while p, which is the quotient here, has to be an integer. It cannot be a decimal. Tell me if this is what you missed. This was the one takeaway then that you're taking from this one. Dividend, divisor, quotient, remainder, they all have to be integers. Okay, yes, that is what we figured out the problem with this one. And now that you've realized once that this is an error that you make sure you never repeat this again. You have to change this into 30 times something, yes, but not by just randomly taking a 2 out of whatever you have and then just leaving it with a 4.5 hanging, which cannot be an integer value. This is why I said this one requires a slightly higher level of processing. You need one more stage before you get to the desired form. See what you have to do. It has to be 30. Yes, it has to be 30. And how will it become 30? It has to be given a 2. But 9 being an odd number does not have a 2 in it. We cannot extract a 2 and leave it with 4.5 as I just said. How do you get an even number? Well, you break your 9 into 8 plus 1. And then you can express this as 15 times 8 plus 15 times 1 plus 3. Now this 8 is good to give you a 2 because it's an even number. So this part here gives you 30 times 4 and the rest of it becomes 18. Are we all absolutely clear from this? And tell me, what is your big takeaway now? What is it that you will always be careful about? Always an integer. All right, quotient needs to be an integer. Even divisor, even remainder, dividend, they're all integers in this one. So this is the one thing you were missing. You cannot take 2 as a factor from an odd number, and 9 was an odd number. So we had to change it into something even, and for that we expressed 9 as 8 plus 1. If it was say 19, I would have written it as 18 plus 1. And then again, I would be able to extract the 2. With this, we are done with this one section, one more section of problem solving. This is the overview here. The first one was pretty basic. This was the first one that you saw. All you had to do was just split 8 and 0.2, and then you got the 30. The next one, what happened was you again split it. You again could get it easily, but this little one here, where you didn't have an even number, you had to be extra careful, and then you had to split it, and then you got the remainder. So overall, you understand how this goes. Tell me how you feel after this section now has ended. Wonderful. So we feel very good. We feel confident. Super. I am your hero. I hope to become a bigger one towards the end of the session. I want you all to leave the session very, very happy. So with this done, we are all ready for the next leg of the session. You know where we're going. We did problem solving questions 600 level. It's time now to go into the 700 plus level this time. So again, they will be GMAT style questions. Make sure you are 200% confident with the concept, everything that we've done till now. Primarily, this equation is the star of the day. This is what we have today. In the subsequent slides as well, we will build upon our understanding of the same concept. Now, before that, there is some things that I want to talk to you about, some extra information, some more knowledge I'm going to give you, some more conceptual clarity, which you will see will do wonders to your question solving. So here's a question. What is the remainder when 31 plus 43 is divided by 7? I will show you two ways of doing this. Typically, people would add 31 and 43 first because you want to find the remainder when this is divided by 7, and then you get 74. So you just divide 74 by 7 and you see that the remainder is 4. Tell me if you are one of these people, if this is the method you would have gone for. Okay, great. So we have a lot of yeses, but we have no's also. That means there are some of you who already know the easier approach, another approach to this one, which is sequence 2. This was sequence 1 of doing this. You actually find the sum first. Sequence 2 is you individually find the remainders of each of these when you divide them by 7 and then add them. Add again because the sign in the middle is plus. So 31 divided by 7 will give you remainder 3 because 7 fours are 28. 43 will give you remainder 1. Then when you add them, it is 4. So you get the same answer. Even in this one, if you feel, oh, this one was easy, I could have added also. Do you realize how this will help you a lot if the numbers are huge? You would not have to actually add first. You see how this is going to be easing your calculations for this one. And this is only about addition yet. Wait till you see multiplication. Let me show you what multiplication has in store for you. So I have 31 times 43 this time. Think about actually multiplying this first of all. Two-digit numbers, you get 1333. Then you divide it by 7 and your remainder comes out to be 3. This is sequence 1. But luckily, we still have sequence 2. That is, we separately find the remainders and then multiply because that is the operation we have in between. So it's 3 and 1 individual remainders. Then you get 3 times 1 equal to 3. See how easy this is compared to actually multiplying this. How many of you already knew this, were comfortable with this already? This earlier, can you see how this is going to help you? Not with the multiplication. Okay, yes, love it. Looks good. Oh, you didn't know this. Wonderful. Now you see how this works and why this works. Let me show you a little about this. Well, I've told you this works, but here is the rationale behind it. Simple and quick discussion here. Everything again depends on your magic relationship, dividend, divisor, and all of those things. See what happens if it's the sum side of it. Well, 31, when you divide by 7, this is the divisibility remainder equation, and this is it for 43. When you add 31 and 43, you're actually adding the right sides of the equation. So 7 times 4 plus 3 added with 7 times 6 plus 1. Now what you see is you can really take this one, 7 times 4 and 7 times 6 together. It becomes 7 times 10, and what you're left with is 3 and 4. So the final equation you have is 7 times 10 plus 4, which is exactly 7p plus r, and your r is less than 7 because it's 4. So you simply add the remainders, and that's why this works. So I'm not just giving you tricks, it is all based on sound principles, everything based on the one equation that we have discussed. Let me show you the same for the multiplication case now. Look here. So again, 31, 43, you want to multiply them. This is what you are multiplying. So it's two terms here, two terms here. How do you multiply them? You multiply everything with everything else. This is what you will get as the expansion. If you look at this first term here, you can extract a 7 from it. It will become 7 times 4 times 7 times 6. Here also you can extract a 7, you will be left with 3 times 6. Here also you can extract a 7, you will get 4 times 1, and this is what will be hanging outside, 3 times 1. So all of this together, when you solve, this whole business becomes your P. I don't even care about the value, and the remainder is 3 times 1, 3. So 7p plus 3. Do you understand how this is working? It should not just be something you memorize. Okay, it works in multiplication. Okay, it works in addition. Do we realize how this is just a straight corollary of what we were doing till now? Yes, it's good to know these things. Yes, you will never feel like you memorized something without having a basis for this. Now with this, we will again go on our journey of solving questions. This is what you will need for the coming questions. So again, tell me you are ready for this with still solving. Great. So I am now going to show you question number 4. Good luck, everyone. Ending the poll in 5 seconds. Make sure you put in your answers. 3, 2, 1, and we're done. Okay, let me broadcast the results first. All right, we have the majority. Not huge this time. 44% of you went with option A, which is correct. A lot of you went with option C. First of all, tell me in the short answer board, what did you do? Did you use our learning from the previous slides? How you could work with addition, multiplication, and if yes, what was your Wow, wonderful. I'm so glad somebody wrote exactly the one point I was going to make here. In this particular question, you have 24 to the power 3 multiplied by 38 to the power 5. You can, of course, work with each of them separately, then multiply and then do all of that. But 24 is divisible by 3. All of us know that. So if 24 is divisible by 3, then anything else that you multiply with 24, the result is still going to be divisible by 3. And if it's divisible, the remainder has to be straight 0. We did not need to do anything at all with the 38 or, with the powers here. So stick to your basics. You don't have to every time you complicate things. Sometimes there's something staring right at you and we miss that because we're just after applying something. You just have to think about, okay, and even if you apply it properly, you would see it's 0 to the power 3 multiplied by 2 to the power 5. Even then, 0 to the power 3 gives you 0, so the result would still have been 0. But it's this quick eye, just seeing that it's 24, which is divisible by 3. It'll save you those few extra seconds as well. This is what you have to be careful about. Well, next one, we have question number 5 again. Let's have still solving. I will know you're ready for this. Have some more votes here. We just have 42 people ready, 91 participants. Let's have more people engaged into this. You are going to benefit a lot from this with proper engagement. All right, great. So I'm now going to show you the next question, question number 5. Good luck, everyone. Last 10 seconds before I end the poll. We're done. Let's see the results, everyone. We have 71% of you with option C, which is correct. A much better majority this time compared with the previous one. while here you do not have anything directly divisible by 3. So I'm sure this time when you looked at this question, you really were on the lookout for something like that. Are they trapping me again, or do I have to do it? Well, you had to do it this time, so you could separately find the remainders. You have 25 times 38 to the power 3, which just means that this expression is multiplied with itself 3 times, and the remainder for each term can be calculated separately and then they can be multiplied. Now, in this case, what you have is you can just take all the 25s first. So you can divide 25 by 3, then you can divide the 38 by 3, get their separate remainders, and then raise it to the power 3. So 1 times 2 is 2, 2 to the power 3 is 8, but remember, I could have given you option 8 here, and I'm sure a lot of you would have gone for that. But here, because we were dividing by 3, the divisor is 3, the remainder had to be less than that. So you apply your divisibility remainder rule one more time on this, and the final remainder becomes 2. So I can read here the multiplication trick is doing wonders. I'm glad you can see how this is helping us. Here is a quick overview of the last two questions and whatever we learned from that. So when it's simple addition, you separate them, find the remainders, add them. Multiplication, you saw, and exponents, powers, are really multiplication only. So 31 to the power 3 just means 31 times 31 times 31. So you find the remainder for the number and then raise the remainder to the power 3. Are we all absolutely clear with this much, first of all? Next up is another great thing you're going to learn, and then you'll see how that does wonders to your calculations. I like the optimism here. I like how everybody's feeling. Oh, you feel that you're upgrading yourself. That's such a nice way to put this. So we can all feel that growth within ourselves. That's the best way to be. Well, now I'm going to show you one more very interesting idea, negative remainders. How many of you know how negative remainders work, or do you know anything about them at all? We see from the results here, there are a lot more yeses than no's. I'm sorry, a lot more no's than yeses. I just have 2 to 3 yeses. Everybody else does not know about this idea. Well then, wait till you're bowled over by this. Look at this. I will tell you something. Well, this is what we've already been talking about, that the remainder is less than the divisor. So we already know that. There's one more fact about remainders, that they have to be greater than or equal to 0. So they can never be negative. Well, you might now feel, if they cannot be negative, then what are negative remainders even? How would they make sense? Well, negative remainders are not something that you ultimately mark as your response, because remainders have to be greater than equal to 0. But negative remainders are that magic tool that you can use to get you to your answer quickly and efficiently. Sometimes using just the positive remainder will you'll just be stuck. You would not know what to do with this because the numbers will get huge. Well, let's see all of that, but first I'll explain how this works. So when I divide 5 by 2, you know the standard divisibility equation is this. It's 2 times 2 plus 1. That is what we all know. But I can also express 5 as 2 times 3 minus 1. So in this case also, I'm really doing the same thing. It's your 2p plus r, just that your r is now minus 1. So this is what a negative remainder is. Ultimately, if somebody was to ask me what is the remainder when 5 is divided by 2, my answer has to be plus 1. I cannot say minus 1. But this is something that will ease your calculations greatly, as you'll see in the next one. Here is another example. when I divide 8 by 3, this is the standard divisibility remainder equation we know about, in which case we see the remainder is 2. This is the other way. You have 3 times 3 minus 1. This again, this time you will see that your negative remainder is minus 1. Now, this again, as I said, this is for ease of processing only. Remember again here, before you mark the answer, you have to convert this negative remainder back to positive. Right now, you don't know how this conversion is going to work, so let me tell you that first, and then you will have the whole package ready. Well, if I talk about this one, 5 divided by 2 only, then this is the equation I told you, the new fancy equation with the negative remainder. How do you convert this minus 1 back to its positive version? You will add and subtract the divisor, which is 2. So it's plus 2 and minus 2. Then you rearrange the equation to put the negative thing, the minus 2 first, and the rest of it, minus 1 plus 2, becomes the other part. Now 2 times 3 minus 2 can be written as 2 times 3 minus 1, and the rest of this yellow piece here becomes plus 1. You see how this went back to the standard divisibility remainder equation that we had. And so you will see that the remainder is 1. Now, this luckily is not what you have to do every time to convert negative to positive. All of this rearrangement in this. Here's a little golden rule for you, highlighted in golden. Positive remainder is straight away the negative remainder plus the divisor. So your negative remainder was minus 1. Just add 2 to it. Minus 1 plus 2 is 1. You will straight away have your positive remainder. I hope everybody is clear with this one. I'll show this one more time with the 8 thing without showing you the entire process. Just appreciate the fact that of the golden rule. If your negative remainder is minus 1, all you have to do is add the divisor to it, which is 3. Minus 1 plus 3 is 2, and that is your final answer. So this is a quick way using which you will come back from your negative remainders to your positive remainders. Now, to help you understand how this is so helpful, we will just have a question number 6 now. You might struggle with this very first one, but then if you don't, you will see the beauty already. Tell me you're ready by marking still solving. Okay, we just have 41 people ready then out of 87 that we have. Come on, show more engagement here. Okay, here is question number 6, everyone. Good luck. seconds more before I end the poll. Right, let's see the results. We have 64% of you marking option D, which is correct. Good, so the majority is again correct. We have 12% and 8% for B, C and B respectively, and 5% for A. Okay, so yes, the majority is correct, but there are votes for other options as well. Let's make sure everybody gets absolutely clear about this. Well, we have this whole thing that has to be divided by 3. Yet again, I can see this first piece, because of the 24 in it, will definitely be divisible by 3. And therefore, the remainder that I get from this little piece will be 0. So all that I care about is this second part, 17 to the power 7. Could we all at least simplify till this? This was a learning from one of the questions we did previously. Wonderful. So we could all understand how this is working. Now then, it's really 17 that we are working with. Now 17 over 3, 17 to the power 7 has to be divided by 3, and this is the remainder that we are after. Now there are two ways again. The straight divisibility remainder equation would give you what? That would be 3 times 6 plus, I'm sorry, we would have 3 times 4 plus 5, and the other one would be 3 times 6 minus 1. So these are the two ways in which I can write my equation. 3 times 5 plus 2, which is 15 plus 2. I said something else, I'm sorry. So it's 15 plus 2 or 18 minus 1. Both of them are 17. Now, if I choose this standard divisibility remainder relationship, it is going to be 2 to the power 7. Now, first of all, you have to quickly be able to do that. Time 2 to the power 7, and then that would definitely be greater than your 3, so you will have to divide again. But if I use this negative remainder, see how the calculations are super simple. It's minus 1 to the power 7, and minus 1 to the power 7 is minus 1, so your final negative remainder is minus 1. But remember, you cannot give a negative answer. You have to convert it back to positive, and how? By adding the divisor to it. So minus 1 plus 3, remainder is 2. We have a question, what happens if it was 17 to the power 8? Well, even then the negative remainder would be quicker to work with. It would just be minus 1 to the power 8, and therefore the final answer would have been 1. It would have been a positive remainder in that case. So if you already got a positive remainder, you would not have to do anything special to it. Are we all absolutely clear about this one? Question number 6. And do you see how negative remainders are helping? Perfect then. Wonderful. So we are all ready for the next one. Let me see that in our still solving for question number 7 then. This is the last one we do before we go back to the hard ones we saw in the beginning. Okay, here we have question number 6. Good luck. Last 10 seconds. Let's have the responses in. All right, so here are the results. I'm very happy with the size of the majority this time, going with the correct answer. We have 83% of you who went with option E, which is correct. Let's discuss this together, and I hope you already are you've bought into the idea of negative remainders, how easy this makes life. So if we start discussing this one, this is the expression you have to work with. You again work with it piece by piece, part by part. You separately do the multiplication, division. Well, this time also, luckily, 24 is divisible by 6, and therefore this entire first expression is divisible by 6. So all I care about is this second piece, 17 to the power 7. When that is divided by 6, I want the remainder. Now again, two ways. The straight divisibility remainder equation is this one on the right, 6 times 2 plus 5. And the one on the left with your negative remainders is this. If I were to work with the positive one only, my final remainder here would be 5 to the power 7, which is huge. So you would first of all need to find 5 to the power 7, and then you would need to further work on it using the divisibility remainder equation. That is why this time, see how negative remainders are super simple. It's minus 1 to the power 7, which is again minus 1. You just convert it to the positive version by adding the divisor to it. So your final remainder is 5. Are you all comfortable with this? And with this, as I said, we've ended the second last section. After this, we will have just our final hard questions. Tell me how you're feeling about it. Why? Wow, I'm glad you could see this. Okay, yes, we continuously conduct sessions. It's every weekend that we conduct such sessions, every Saturday, Sunday. You will learn more about it towards the end of the session. Atreya will talk about it. This is great. All of us are all ready for the hard one. Okay, we have a question. What if it was 21 raised to the power 7? Well, if it was 21 divided by 6, then if you do it straight, then you would have 6 times 3 plus 3. And if you do the negative, it's 6 times 4 minus 3. So in that case, negative, positive would both not be of much use for us. It is not going to be a GMAT style question where they expect you to do that. And if that comes, there's you know what they're doing, they're really expecting you to know 3 to the power 7, because if you actually sit and multiply 3 with itself 7 times, that's going to be too much calculation for GMAT. GMAT is a smart test. It does not care too much about multiplications and divisions, about calculations. You have to know how to do these things smartly. So that question will not be there. Don't worry about it at all. So we are now just reviewing this, the last two questions. We had negative remainders, how they could simplify calculations. These, in fact, came together with what we learned earlier about addition and multiplication also. So everything together made your job very, very simple. All of these learnings you have to take with you on these final set of 3 hard questions. Please be very careful. Make sure you're comfortable with everything. All the very best. Tell me you're ready for this one. I will just clear the responses. Tell me you're ready by clicking on Still Solving. Okay, we just have 39 people saying still solving. Let's have more votes. We are more people. We have 80 people here right now. All right. Wonderful. I'm glad the moment I say please mark it, you do it. Do it for the first time only. Here is question number 8, everyone. Good luck. Last 30 seconds, everyone. Do not rush through this. 30 seconds is enough. You know the concepts. Trust yourself. Ending the poll in 3, 2, 1. Okay, let me broadcast the results. Well, I am very happy because I know what was the result the first time we did this. Remember, I showed you the results. I don't expect you to remember that. By that time, I had 25% of you voting for option A. And now we have 54% of you. You can see 25 doubled is 50. This is more than that. And the correct answer is A. So we have had a huge shift, and a lot of you now have marked this correctly. We still have 30% of the people marking option C. Even then, C was a huge contender. In fact, C had the majority then. So it has flipped. A has become the main one, but C is still standing. I see how people are still feeling we need them together. So let's discuss this, and I am very, very sure that there is something very basic that the people who've marked C are missing. Let me just discuss this, and then I will talk to you one more time about this. All right, so what is the remainder when P is divided by M? And statement 1 tells you P is this thing. I don't know the value of M, and so I don't know the value of P either. But I know this relationship between P and M. Now, for people who marked C, I feel it's the fact that you don't know P, you don't know M, how can I get the remainders? Please confirm my understanding if this is how you thought. That in statement 1 alone, you get no values of P, no value of M. Okay, so you say yes. Now see the magic here. You don't even need the remainder, you don't need the dividend, you don't need the divisor, you still can get the remainder. Look at this here. Well, m plus 1 over m plus 1 to the power 8 is being divided by m. And you know how the power can just be taken out? So you will just have to divide m plus 1 by m. Now, I don't know m, yes, but m plus 1, break it down into two more pieces. When you take just m is always divisible by m, so the remainder from there is 0. But when 1 is divided by m, 1 is divided by any number. Look, you know m is greater than 1. So 1 is divided by 2, 1 is divided by 3, 1 is divided by 4. Since 1 is smaller than all of them, say it's 1 divided by 6, all you can say is 6 times 0 plus 1. So the remainder is going to be 1. Another way you can see this is that m plus 1 is 1 more than m, say 12 by 11 or 59 by 58. The remainder is always going to be 1. So it's 1 to the power 8 and the final remainder is 1. Does everybody who marked C understand this? It was a huge portion here, so we have to make sure we're all very clear about it. Great. So everybody understands this now. Now this here teaches you something very important. Do not jump to conclusions without trying. Try it. Write things down. Think a little. You might be able to infer something from it. Just looking at things, oh, I don't know P, oh, I don't know M, you might miss something very, very important. So at least try everything, give everything a fair share, of your thought. Give some time to it. With this, now I know that statement 1 is sufficient. Thank you for that wonderful compliment. Thanks a lot. So we have these options. B, C, and E are out. The only contenders are A and D. D would be if second statement is sufficient as well. Now if I talk about statement 2, let's see. Well, statement 2 just tells me the value of M. I know nothing about P. It's P divided by M, right? You don't even know the dividend. You've got nothing that you can do here, right? So with this, when I really know nothing about the dividend, there's no way I can get the answer. So second statement alone is insufficient, and therefore the answer is option A. Are we all absolutely clear about this hard question now? You should be crystal clear no matter how hard it seemed in the beginning. And does it seem so hard now that you've talked about all of That's so great. See, it seems easy. Why? Nothing changed. The question is still what you saw earlier. But now you have the right concepts, you have the right skills. This should give you the confidence to prepare for the GMAT. If you're struggling with any section, just trust yourself. With the right preparation, whatever seems difficult to you today will start seeming easy to you tomorrow. Just trust yourself, go with the flow, follow a proper methodical approach. Don't go for shortcuts, they don't work every time. With this now, I will take you to the second hard question, which was question number 9. Tell me you're ready by marking still solving. Okay, here is question 9. Good luck, everyone. Last 30 seconds to mark your answers. The poll is now ended. Here are the results. You see something very interesting here. Option A has 35%. Option D is also exactly 35%. And you know, both of these cannot be correct. So almost half of us are with A, the other half is with D. Almost. We have 13% of you with option C as well. Well, the correct answer is A. Let me start with the good news first. When we first did this, the accuracy was just 13%. So if you go from 13 to 39, it's almost 3 times the accuracy now. So there is a growth in the group, but there's a huge portion that still feels it's D. That means you feel statement 2 is also sufficient. So my focus here will be on talking about statement 2. Let's start discussing this. Well, 38 divided by 13 to the power n squared. This is the remainder that we wanted. Now, 38, when you use the divisibility remainder equation, of course you go for the one with the negative remainder because the value is just -1. So it's essentially -1 to the power n squared. Now this depends on n. If n is even, you get -1 to the power even. That means you get your remainder as a +1. But if n is odd, then n squared is also odd. Your remainder is -1, which you will have to convert to a positive remainder by adding 13. So my final answer depends on the even-odd nature of n. I hope everybody is clear till here. Tell me if this much is absolutely clear, that everything depends on the even odd nature of n. Okay, so when we see, I see some no's also. So let me just quickly go over this again. We had -1 as the negative remainder, which we had to raise to the power n squared. Had this been -1 to the power 7, then I know it's -7. If it's -1 to the power 8, I know it's +1. -1 to the power 8. But in this case, I don't know what my power is. I don't know whether it's even or odd, right? N is positive does not make a difference. When you raise -1 to 7, it's the reason that 7 is odd that the answer is still -1. And -1 to the power 8, it's because 8 is even that you get a positive one. It has got nothing to do with the sign of n. In fact, if n was negative, then this would mean this final thing goes in the denominator. -1 to the power -10 just means 1 upon -1 to the power 10. So that's completely different. That is something else, not what we're doing here. So it depends on even odd. So yes, positive, negative got me. So this is the error most of you made. So with that, now that we're clear that it has to be between even odd, we have to think about just that much. Now, when I come to statement 1, I get n leaves no remainder when it's divided by 4k. So writing it like this, 4k plus 0, it just means n is a multiple of 4, so it's even. And remember, all you cared about was, is it even, is it odd? So statement 1 does tell you clearly that it is even. So if it tells you clearly what you were looking for, statement 1 is sufficient. Now, since a lot of you marked D, obviously you thought this was sufficient. So the main trick here is in statement 2. Let me talk about that now. Well, square root of n is only divisible by 1 and itself. Now, a number that's only divisible by 1 and itself is a prime number. That means square root of n is a prime number. So n itself is what? It's a prime number squared. Now, a prime number can be 2 also, which is even. Right? So 2 is the only even prime number. The others are all odd. So because of this, n could be even or odd. So people who did not consider 2 missed this. You might have thought, oh, it's always odd, so I know clearly what it is. 2 is in fact the only even prime number, but it is there. You have to consider all the cases. Remember, I talked about considering all the cases. This is the one mistake you made, most of you who marked D, as I can read in the comments here as well, completely missed 2. So make sure you consider everything. Don't miss something so basic. This is where prime numbers begin. How can you forget the very first prime number? So be careful about this. Because of this, then, statement 2 does not clearly tell us whether n is even or odd, and so statement 2 is not sufficient, and your answer is option A. Are we all very clear now? We had a huge majority that was wrong, so I have to make sure everyone is clear with this. Okay, great. A lot of you say you're clear, but 0 is also an even number, right? Yes, 0 is an even number, but here we're looking for the square of a prime number. 0 cannot be a prime number. The smallest prime number is 2, nothing else. Why go with the r equal to -1 and not r equal to 12? Well, you know the reason for that. If I had taken this as 12, then I would have to raise that to a power of n squared. Well, 12 to the power 5, 12 to the power 4, that itself is difficult. Here I don't even know the power. It's n squared. So that is going to be super complicated. Working with -1 is very easy when you work with powers. Exponents are become so simple when you have -1. It's just either -1 or +1. That is why you went for negative. So with that, I hope everybody is clear with this. I will clear the poll. Mark still solving to tell me you're ready for the last challenge question. Okay, here you have question number 10. Good luck, everyone. Last 20 seconds before I end the poll. All right, let's see the results. Okay, so the majority has gone with option D, which is correct. Good. The accuracy for this one, when we first did it, was 40%. So from 40, it has gone to 60. So it has increased. You people are learning what's happening. A and B have 23 and 13. So together that's 36%, which is a huge proportion of all those people who did not mark D. Most of you who did not mark D went with A and B. That means D is the answer, means both of these statements are sufficient. But a lot of you thought only the first one was sufficient or only the second one was sufficient. So people who marked A will have to listen carefully about statement 2. People who marked B, be very careful when I talk about statement 1. Now let's start with this and let's hope to have everyone together on the same page by the end. You want to find the remainder when 4m is divided by 16. So this is how you can express it, and you know the divisibility remainder equation is this. So it has to be 16q plus r, where r is the remainder that you want to look for. And by now you know r has to be less than the divisor, so it's less than 16, which means it can be 15 or less, and it has to be greater than equal to 0. So this is what I want. Now what I have from statement 1 is that m leaves a remainder of 4 when divided by 32 to the power 32. So this fact again I can express using the magic equation like this. So my goal is to talk about 4m. What I have is just m. How can I get 4m? I will just multiply 4 on both sides, and this is what I will have. Now remember, your goal is to have 16q. So 16 times something, but what you right now see here is just a 4. How do you get the other 4 to make it 16? Well, 32 to the power 32 has ample of those. You'll just take 132 away from this. So it's 4 times 32. And the other 32s, how many? 31 of them stay on the other side. Now this 32 can give you the 1 4 that you were looking for. Remember, you wanted to become a 16. You already had a 4. You just wanted one more. So you extract a 4 from 32. The 8 is what is left behind, and the rest of this portion we have written as it is. Now with this it becomes 16 times, where do you go till p? This much, everything. 16 times all of this is p, and on the end you have 4 times 4, which is 16. So 4m is equal to 16p plus 16. You can take 16 common. It's 16p plus 1 plus 0. So 4m is divisible by 16, and therefore the remainder when you divide it by 16 is 0. So everybody who marked B, do you understand how statement 1 is also sufficient? Come on, 13% of you marked B. That means you thought statement 1 was not sufficient, only statement 2 was. If you understand this, you will directly reach option D, which is the correct answer. Explain the second to the third line. Second to the third line. Here you mean? So what I wanted was to have a 16. So how do I get a 16? I already had 4. From this 32, I have taken out 4. So I've written 4 as, let me just clear this up and write again. So from this 32, it just comes back all together. So I'm sorry. So 32 is 4 times 8. So I'm taking this 4 and the 8 becomes a part of the rest of it. Now with this, okay, most of you say you've understood this. We will go to analyzing statement 2, which is that m cubed is divisible by 16. 1 second. All right. If m cubed is divisible by 16, then I don't know what even m is first of all. But I know one thing, that m cubed is even. If something is divisible by 16, it's definitely even, right? And if it is even, then m is also even. If a cube is even, then the number itself is even. And if it is even, it will definitely have 2 as a prime factor. So this is how I can express the prime factorization of the number of m. Now, this is m cubed. This is just m. How do I get m cubed from that? You will cube both sides. Right side becomes 2 to the power 3a, p1 to the power 3b, and so on. Now, we know a fact that this is divisible by 16. But what is 16? 16 is equal to 2 to the power 4. I can read some. Your voice is breaking. Are all of you facing this problem? Please tell that to me in the yes no pod. Do you have a problem hearing me, or you can hear me fine now? Okay, so you cannot hear me properly. Then I see a lot of no's. Okay, now working? Great, it's better now. Thank you, thank you. So I will start over with statement 2 so that everybody gets back. Statement 2, we had that m cubed is divisible by 16, which means m cubed is even. Anything that's divisible by 16 is an even number, and therefore m is also an even number. If m is an even number, it definitely has 2 as a prime factor. So this is how the prime factorization of m can look. Then we had m to the power 3 really that you were talking about. So you cube both sides, and this is what your right hand side becomes. 2 to the power 3a, p1 to the power 3b, and so on. Now we know something about this, that this is divisible by 16, where 16 is nothing but 2 to the power 4. Now what I can see here is that it's 2 to the power 3a. But it has to be divisible by 2 to the power 4, which means 3a has to be at least 4. That much has to be there. So if 3a is greater than equal to 4, then a is greater than equal to 4 by 3. But a is an integer here because it's the number of 2's you have, right? It's 2 to the power a from here. So what is the minimum number which is greater than or equal to 4 over 3? That is 2. So the minimum value of a is 2. Now that tells us something very important about m. So from this prime factorization, I can say m is 2 to the power 2 times something. Why? Because I know it's a minimum of 2. The power of 2 is minimum 2. It's the rest of it is something. I don't know whether I have any more 2's or not, but this much I'm sure of. Now my question is about 4m. So I will multiply both sides by 4. The right hand side becomes 4 times 2 squared. What is 4 times 2 squared? It is 16. So it is 16 times something. Let's just call that q, which means 4m is divisible by 16. So the remainder when you divide it by 16 is 0. So we could get the remainder even from statement number 2. Are we all clear about this now? A lot of you marked option A. This is what we had missed. Yes, this is hard. This one requires a lot more processing than the others. So when you get the recording of the session, please make sure you go through this very carefully and try to understand every piece that I talked about here. This was hard. It's okay. for a first time, it can feel difficult. But again, what you're ultimately doing is you're just trying to see 4m as 16q plus something. So if m had at least if m had at least two 2's, then 2 squared was guaranteed. So the moment you multiply a 4 with it, with a 2 squared, it becomes 16. So 16 is definitely there, and therefore your remainder is 0. Now this was the answer for the question option D. Now with this we are done with all the questions that we had to do today. This is hard again, trust me, go through the session, go through the PDF of the session that you see, spend more time on it, and you will feel more confident.